Hello guys, welcome to another video. Today we'll deal with the factorization of quadratic expressions. Factorization means to factorize, and factorize means to resolve into factors. In the previous videos, when we were expanding algebraic expressions, each bracket was made up of a linear expression. Let's say we had something like, the example, we had x plus 2 and an x plus 3. Okay, we see that each of these expressions is made up of a linear expression. So this is a linear expression in the first bracket, and this is a linear expression in the second bracket. So what is a linear expression? A linear expression is any expression of the form ax plus b. So this is called a linear expression. And notice that for this to be called a linear expression, the condition is that a should be different from 0. Because if a is 0, this term will be 0, and we will be left with a constant b. And this will no more be called a linear expression. And we see that this is a linear expression where a here is 1, that is the coefficient of x here is 1, and b is 2. Here is a linear expression where a is 1 and b is 3. Now, we see that when we multiplied these two expressions, we had something like x squared plus I multiply this by this, we have x squared, this by this, plus this by this, which gives 5x, and this times this gives 6. We notice that the highest degree of the variable x is 2, that is, the power is 2. And when we have such an expression, we call it a quadratic expression. So what is a quadratic expression? A quadratic expression is any expression of the form ax squared plus bx plus c. So this is called a quadratic expression. And again, here the condition is that a should be different from 0 because we want to maintain the highest degree, which is 2. So we see that, let me write this, x plus 2 and x plus 3 gives x squared plus 5x plus 6. We saw this in our previous videos. For those of you guys who haven't watched yet, I'll put the link in the description, so you're free to watch. So we saw that moving from here to here is known as expansion. So what we are required to do now is to move from here, that is from the right hand side to the left hand side. So we're required to move from here to here. So we want to convert this quadratic expression into factors. So by doing this, the process is known as factorization. So that's what we're required to do. And here we notice that the coefficient of the term in x squared is 1, is a product of the coefficient of this x and x. So 1 times 1 is the coefficient. And the constant 6 is the result of multiplying the constant of both of these linear expressions, 2 times 3, which is 6. And the coefficient of the term in x, which is 5x, the coefficient of the term in x, which is 5, is a result of adding the two constants. So that's how we usually get move from the right hand side to the left hand side. So notice that 2 and 3 are factors of 6. So to get the sum, that is to get 5, we need to find the sum of the factors of 6, which when multiplied will give 6 and added will give 5. So that's it. So if I have something like, let's say I have x squared plus 5x plus 6, I need to resolve this into factors. What I do is that I find the factors of 6 that which when multiplied will give 6 and when added gives 5. So automatically I think of 2 and 3. Another 2 times 3 gives 6, and 2 plus 5, 2 plus 3 gives 5. So I have something like x plus the first factor 2 and x plus 3. So that's how I move from here to here, and I factorized this quadratic expression. Let let's have another example. Let's take this our first example. Let's take the second. We have let's say we have x squared plus 8x plus 12. Okay, this one we'll do the same thing as we did for the first example. Here we'll look for, we notice that the coefficient of xy is 1. So when it's 1, we look for the factors of 12 that when, two factors of 12 that when multiplied is 12 and when added is 8. So I can enumerate my list of factors of 12. I have 1, that when multiplied gives 12. I have 1 and 12. I know that 1 times 12 is 12. Another 2 and 6. 2 times 6 gives 12. And I have 3 and 4. These are my list of factors. And in each couple, I notice that the only one which when added gives 8 is this one. That is 2 plus 6 gives 8. And 2 times 6 gives me 12 equally. So that's I will write my factorization as x plus 2, the first 2, and x plus 6. And that's it. Let's take another example. Let's say we have x squared minus 9x plus 8. I do the same thing. I find the list of factors of 8. So I have 1 and 8. I know that 1 times 8 gives 8. I have 2 and 4. 2 times 4 gives 8. And that's it. These are the possible factors. And I will try to look for 2 that when multiplied gives 8 and added gives negative 9. So I know that the coefficient of determining x is negative 9. So how can I get negative 9 from these factors? I need to insert a negative 9 in each of the factors so that when added gives a negative 9. So let me try this one out. I know that the multiplication must give a positive 8. So I have a negative 1 times a negative 8 for this first one. So multiplying these 2 gives 8. And adding these 2 gives, that is negative 1 plus negative 8 is negative 9. And that's it. So I write this one as x minus 1 and x minus 8. And that's it. And let's have number 4. Let's say I have 4 plus 5x plus x squared. Here, it's the same principle. I can write this one, inverse this one as x squared. That is, I start writing from the right hand side to the left hand side. So x squared plus 5x plus 4. I have this. And I do the same thing. Look for 2. Notice that the coefficient of the term x squared is 1. So I find 2 factors that when multiplied gives 4 and when added gives 5. I have my factors 1 and 4. I can either have 1 and 4 or 2 and 2. Are the possible ways. But I noticed that the only way I can have 5 is by adding 1 and 4. That is 1 plus 4 is 5, and 1 times 4 equally gives 4. So here I have x plus 1 and x plus 4. And that's it, guys, for the factorization of quadratic expressions. Thank you guys so much for watching. Please comment, like, and subscribe. You might share this video to the people you know it will help. Thank you for watching and stay tuned for perpetual videos. Bye.